2, Lesson 4, Routing and Redundancy. In this lesson, you'll be able to explain how data is routed through the internet and describe how the redundant nature of networks can lead to dynamic, fault-tolerant routes. Now, as beginning, we're going to warm up. Think about this. At the end of the last lesson, we saw that the internet uses the Internet Protocol and IP addresses to communicate across the shared network. How is this system similar to how we send letters in the mail? And how is it different? Jot down what you think and see what we come up with as we continue through the rest of this lesson. And if you're simply tuning in and you're not attending the lesson and not reviewing it here, we have to and from addresses. The mail system has a physical letter carrier. The internet goes over electrical wires and connections, and even through the air. There can be some other differences and similarities we're going to see as we continue the lesson. Some obvious similarities: both systems involve a numerical address that helps identify where the letter should go. Both a to and a from address are needed. A subtle similarity that you might not realize: our postal system has several intermediary steps before it reaches the destination. It is picked up by a postal worker, sorted in a postal center, and eventually directed to the recipient. This point is helpful in our foreshadowing of how today's lesson builds on yesterday's activity, or on this current lesson builds on the previous lesson, and the introduction of routers. In this particular lesson, we are going to investigate how the Internet Protocol helps us communicate on the internet, and we will use some new devices called routers to help manage how we communicate. Now, our activity. First, everyone should go to code.org and log in. Okay, so pause the video at this time to do that. Okay, today, again, you should go to Unit 2, Lesson 4. Today, we're going to be using a new version of the Internet Simulator that incorporates the IP addresses we learned about yesterday or in the last lesson. In fact, when you log on to this Internet Simulator, you will notice that now everyone has their own IP address. This will be important in today's simulation. Please note below which group you are in. Currently, you'll notice that all the groups are blank. Prior to the lesson in class, I will put everyone in a period into a group. So you will have 3 to 4 people per group. Now, Unit 2, Lesson 4 activity. Please, again, make sure that you are logged into this. And we're going to look at this updated Internet Simulator. So you can open the Internet Simulator, okay, and connect to the same router number as your group. They'll have some of these routers out there. So you simply go out there and over here you're going to click Join. Once you've done this, say hello. Use the updated version of the Internet Simulator to send a message saying hello to everyone in your group. Everyone now has an IP address. This again will be important in today's simulation. Now, in the previous lesson, everyone was directly connected to everyone else, and we could see, or you could see, all of the messages. In today's lesson, we're connected to a router, which helps to decide which messages we receive. We can even take a look inside the router in order to see the decisions being made. Let's do that now. Let's open the router logs. So go to where it says the log browser and open it, and look at the messages. Here we notice a timestamp logged by router 2. It was a successfully sent message. It was from 2.9 to 2.14, and it said hello. Okay, notice our IP addresses are not real IP addresses. They're not nearly as long, but they are unique. Now, if you're doing this all on your own, while you won't have other people, you could see if a friend in another class could log on and do this short activity with you. Now, open the router logs. View all the messages, not just your router, but for all routers. So over here where it says My Router Logs, Show All Traffic, instead of Show My Router, click the pull-down menu and click Show All Routers. Now, at this point, you're going to see all kinds of crazy stuff. And okay, just take a look at it, see what it says. Now, what I'm going to want everybody to do is use the router logs to choose an IP address from each of the other routers. So select one IP address from each one of the other routers. So if we had 8 groups, there are going to be at least 7 other routers. I want you to take and send each person a message asking them who they are and choose one of the following questions. You don't choose one of the following, you select it and ask it to them. So you can ask everybody, what is your favorite food? What is your favorite type of animal? What is your favorite color? Any one of those. And they should reply by answering who they are and the answer to this question. Go ahead, and if you're working with somebody, do that now. Now you can open the router logs again, and this time you should see a lot more messages. Here's an example. I've got the timestamp, and notice it's logged by lots of different routers. Tells you if it was successful, or down here, notice there's one that was dropped. It was coming from someone to someone, from router 5, person 5 to router 6, person 12. First time was 685, second time was 61385. I don't know what that was, but this one is, hello Lillian, this is Vicki from router 13.2. And look, that message is repeated 4 times. Cool beans, repeated 4 times. K was repeated 3 times. This one, hey, did you get my message? That was dropped. He's ignoring me, twice. Can you predict why some messages are appearing multiple times? Think about it. Pause the video and jot down what you think. Well, our messages are being sent from router to router, bouncing between different routers in the network. Not all messages take the same path to get to their destination. In fact, even when sending multiple messages to the same person, messages may take different paths. Sometimes there's a lot of traffic. Sometimes there's a roadblock. Okay? I want you to do this. I want you to pick someone on a different router, one person on a different router, and send that person 3 messages with your top 3 favorite movies or TV shows. After you send the messages, open the router logs and find these same messages in the logs. And I want you to notice how these messages travel through the network. And did they always take the same path from your router to the other router? Look at other messages that are being sent. Are there any patterns in the paths that they take? So pause the video, and again, if you're working with somebody, do these things. Okay, you're back. What did you notice about the messages that you sent in the logs, in the router logs? Did they always take the same path from your router to the other router? Here are some things that you need to know. A router, it's a type of computer that forwards data across the network. Redundancy, the inclusion of extra components so that a system can continue to work even if individual components fail. For example, by having more than one path between any 2 connected devices in a network. Fault tolerant, something can continue to function even in the event of individual component failures. This is important because elements of complex systems, like a computer network, fail at unexpected times and often in groups. Don't write these definitions down just yet. First, think about these: router, redundancy, and fault tolerant. How can we describe what we observed in the router logs at the end of this activity? What are some practical reasons that you think messages might take different paths from one router to the other? Pause the video and jot down your thoughts. Okay, you've jotted down your thoughts? Well, since this is a video and we're not going to have a class discussion here, I'll describe a few things. 1, they take different routes due to traffic. If there's a lot of traffic going through a particular router, then it's going to look for an easier path to go through. Likewise, if for some reason there's a broken connection or something like that, then again, it's going to go in a different direction. So a lot of times it has to do with the existence of an error or no error on the line, or of just the volume of traffic. Let's face it, we've all been in the car and you decide to take a longer route to get to your destination just because you will keep moving. The mileage might be greater, but the time could be far less. Okay? Now, at this time, write down in your notebooks, pause the video, and write down these vocabulary words: router, redundancy, fault tolerant, and the corresponding definitions. You should have paused the video because that's the end of this lesson. And what comes next? Why, packets, of course.